Hello everybody, how are you people? I'm over here back again with a very new session of our Strate-JEE series and आज का जो topic है that is thermal properties of matter. So I suppose all of you must have been waiting. So जल्दी यार अपने सारे काम वाम जो भी हैं आपके साइड रखो for the next 1 hour. जस्ट फोकस ऑन दिस सेशन जिसमें हम प्रीवियस ईयर बहुत सारे अच्छे इंपॉर्टेंट क्वेश्चन सॉल्व करेंगे एंड बहुत अच्छी अच्छी बातें भी करेंगे. ठीक है, सो फर्स्ट ऑफ ऑल चैट में बताओ आप कितने लोग अवेलेबल हो, क्या मैं ऑडिबल हूँ, क्या मैं विजिबल हूँ और क्या हम जल्दी ही सेशन को किक स्टार्ट कर सकते हैं. सेशन की बात करते हैं. स्ट्रैटेजी सेशंस, दीज आर previous year question series which is exclusively run by Extramarks on its YouTube JEE channel, जिसमें हम प्रीवियस ईयर के जेई मेन और एडवांस में जो भी इंपॉर्टेंट क्वेश्चंस पूछे गए हैं जिसमें स्टूडेंट्स ने मैक्सिमम डिफिकल्टी फेस की है, उन सारे क्वेश्चंस की एक सीरीज लेकर आए हैं जस्ट फॉर यू पीपल, जिससे कि आप अपने ऑनगोइंग प्रिपरेशन को और बूस्ट अप कर सको. साथ ही साथ ऑल दोज पीपल, ऑल दो स्टूडेंट्स हु आर इन देयर 11th क्लास, 12th क्लास और इन द ड्रॉप ईयर और इवन इन द 9th and 10th क्लास हु आर aspiring to clear JEE one day, they are actually टोल्ड टू अटेंड दीज सेशंस. बहुत ही ज़्यादा अच्छे हैं. मतलब आप इनको अटेंड करो, यू विल गेट टू नो हाउ क्वेश्चंस हैव बीन आस्क्ड एंड कैसे कैसे क्वेश्चंस ने ट्रबल क्रिएट किया है स्टूडेंट्स के लिए उन दोज 3 hours. सो दिस विल गिव यू अ वेरी गुड इंसाइट. आई एक्चुअली वांट टू टेल यू, आप ऐसे सेशंस को रेफर भी करो अपने दोस्तों को जिससे कि उन्हें भी पता चले. एंड थैंक्स अ लॉट आप फॉर योर लव एंड सपोर्ट विच यू हैव शार्ड ऑन अस. हमारा सब्सक्राइबर बेस हैज़ इंक्रीज्ड एंड दैट्स ओनली एंड ओनली बिकॉज ऑफ यू पीपल. सो थैंक्स फ्रॉम द बॉटम ऑफ माई हार्ट एंड आई रियली वॉन्ट मोर सपोर्ट फ्रॉम यू, जिससे कि हम ये इंपॉर्टेंट अच्छे इनोवेटिव सीरीज और सेशंस को और लोगों तक भी फैला पाएँ. ओके, विद दिस वील जस्ट गिव यू एन इंट्रोडक्शन अबाउट दिस सेशन. ये एक लाइव सीरीज है स्ट्रैटेजीज जिसमें हम प्रीवियस ईयर क्वेश्चंस को बताते हैं. साथ ही साथ बहुत सारी आपको स्ट्रैटेजीज बताई जाएंगी हर क्वेश्चन को सॉल्व करने की. एक ही क्वेश्चन को किस और तरीके से कोई बेटर मेथड से सॉल्व कर सकते हैं. साथ ही साथ द यूनिक फीचर विल टेल यू द एरर एनालिसिस इन ईच क्वेश्चन. सी, एरर एनालिसिस इज वेरी वेरी इंपॉर्टेंट टू सॉल्व अ क्वेश्चन एंड टू नो अबाउट. सी, I have always felt that solving a question is just like moving on a right path. And obviously your final destination is very clear, but there are so many paths and every path is not leading to that final destination. So you should know those wrong paths, then only you can actually sort them out or filter them out in your examination day and choose that right path. So this is actually in accordance with the error analysis. Error analysis आपको ये बताता है कि इस क्वेश्चन को सॉल्व करने में कहाँ कहाँ आप गलती कर सकते हो, where are the areas where you can have a potential जहाँ आप गलत कर सकते हो. सो उन सारी चीज़ों को अवॉइड करना प्रायर रहकर बहुत ज़रूरी है. बिफोर हैंड वी शुड नो कि इस टॉपिक से ज़्यादा क्वेश्चंस आते हैं, जिससे हम इस टॉपिक पे ज़्यादा क्वेश्चंस की प्रैक्टिस कर पाएँ, ज़्यादा टेस्ट दे पाएँ, जिससे कि हमें फाइनल एग्ज़ाम में जिस दिन हमारा वो जेई मेन का 3 घंटे का सेशन होगा उस दिन हम पैनिक ना कर जाएं और सिली मिस्टेक्स ना करें या गलतियां ना करें जिससे हमें नेगेटिव ना मिले. ओके, सो दीज सेशंस आर स्पेशली डिजाइन फॉर यू पीपल एंड इसी सेशन के साथ आगे बढ़ते हैं. एंड लेट मी गिव यू अ ब्रीफ अबाउट माई सेल्फ. माई नेम इज आदर्श राय एंड आई एम अ ग्रेजुएट फ्रॉम NIT भोपाल. I myself has cleared this exam way back 6 years previously to this session, and from past 6 years I have been mentoring students for competitive exams like JEE and NEET as well. If I talk about Extramarks, so Extramarks has a very good repo in JEE NEET segment, wherein we have ensured that out of every 7 students who are enrolled or had been in our course, one has been selected in JEE Main, and that's a very good figure. And we don't claim it to be the best because we are still working on it. And I'm sure the next year when I'll be showing you this result, the result will have at least twice or thrice of its present value. Then if I talk about the application which I'll be giving you the interface, आपको लिंक ऐप का डिस्क्रिप्शन में मिल जाएगा, सो यू कैन डाउनलोड इट. एंड ऐप पे जो कंटेंट है इट्स टू गुड, इट्स एक्चुअली वेरी वेरी गुड. आई माई सेल्फ हैज सीन इट एंड आई जस्ट विश जब मैं प्रिपेयर कर रहा था तो ऐसी कोई ऐप आती जिसमें इतने प्रॉपर तरीके से क्वेश्चन सेगमेंटेड हैं क्लास के हिसाब से, टॉपिक एंड सब टॉपिक्स के हिसाब से भी, सो दैट आई डोंट हैव टू हंट फॉर अ पर्टिकुलर बुक. जहाँ पे देखो देर आर सो मेनी स्टैंडर्ड बुक्स अवेलेबल इन द मार्केट, बट द ओनली द प्रॉब्लम इज वो कंप्लीट नहीं है, दे आर नॉट कंप्लीट इन इटसेल्फ. फ्यू बुक्स आर वेरी गुड फॉर सम टॉपिक्स बट एक्सेसिव फॉर सम टॉपिक्स एंड इनकम्प्लीट फॉर सम टॉपिक्स. सो यहाँ पे आपको सारी ही चीज़ें, फीचर्स एक साथ एक ही प्लेटफॉर्म पे अंडर वन रूफ यू कैन गेट इट. सो इट्स स्टील डील फॉर यू गाइज. ठीक है, सो आपको डाउनलोड करो. और यहाँ हमारी टीम ने जो कि ऑलरेडी IITN और NITN की है, जो ऑलरेडी इस एग्जाम को क्लियर कर चुके हैं, दे हैव बीन व्यूइंग द एग्जाम्स फॉर पास्ट सो मेनी ईयर्स, दे हैव सो रिच एक्सपीरियंस, दे हैव एक्चुअली क्यूरेटेड दैट कंटेंट. सो यू शुड डेफिनेटली गिव इट अ ट्राई. आप डाउनलोड अभी कर सकते हो डिस्क्रिप्शन में जाके, बस लिंक पे यू नीड टू प्रेस, एंड दोनों ही ऐप स्टोर और प्ले स्टोर दोनों पे वो अवेलेबल है. ठीक है, देन थर्मल प्रॉपर्टीज ऑफ मैटर की बात करते जो आज का सेशन है. सो नियर अबाउट व्हाट आई हैव सीन इज कि अराउंड 1 और 2 क्वेश्चंस इस चैप्टर से आते हैं, जहाँ पे आपका कंडक्शन की बात हो गई कि हीट ट्रांसफ़र कैसे होता है, देन उसके बाद थर्मल एक्सपेंशन की बात हो गई. एंड इसके कॉन्सेप्ट्स सी 11th के जो कॉन्सेप्ट्स हैं, क्वेश्चंस कैन बी आस्क्ड डायरेक्टली फ्रॉम दोज कॉन्सेप्ट्स आल्सो, एंड questions in advance can be asked with the uses of this concept, with the uses of fluid mechanics, and just imparting them up in electrodynamics. So you can experience a question like that over there. Okay, so mixture of concepts के questions हमेशा एक favorite hot topic रहा है JEE का, और हमेशा स्टूडेंट्स को ट्रबल भी उन्हीं चीज़ों से होता है जहाँ पे मिक्सचर ऑफ कॉन्सेप्ट्स आ जाते हैं. कुछ 11th के टॉपिक उठा लिए, कुछ इधर के उठा लिए, एंड ट्रस्ट मी क्वेश्चंस ज़रूर आते हैं. और इसमें से जो फेवरेट हॉट टॉपिक्स हैं जिससे मैक्सिमम क्वेश्चन आते हैं, वो है कोएफिशिएंट ऑफ एक्सपेंशन. आप ये लीनियर कोएफिशिएंट बोलो या वॉल्यूमेट्रिक बोलो या सुपरफिशियल बोलो, सबसे ही कहीं ना कहीं उसका इन्फ्यूजन रहेगा. द नेक्स्ट इंपॉर्टेंट टॉपिक है वर्क डन इन अ प्रोसेस, कि वट एवर द टाइप ऑफ प्रोसेस इट बी, आइसोबारिक, आइसोकोरिक, उसमें वर्क डन क्या है. सो उससे रिलेटेड काफ़ी ज़्यादा क्वेश्चंस आते हैं. देन साइक्लिक प्रोसेसेस में डेल्टा यू क्या होगा, देन डेल्टा यू जीरो होगा तो बाकी और डेल्टा क्यू एंड डेल्टा डब्ल्यू क्या होगा, या पी या वी की वैल्यू कैसे होगी अगर एक साइक्लिक प्रोसेस चेंज हो रहा है. सो ऐसी सारी चीज़ें बहुत सारी आएंगी. देन ग्राफिकल एनालिसिस, वेरी वेरी इंपॉर्टेंट. आई शुड टेल यू, PV curves and VT curves and TV curves, they are asked, and there is no one year जहाँ पे questions नहीं आते. और there are graph question. Graph has always been a very favorite topic. या तो वो ST VT AT से आ जाएंगे graphs, या फिर इससे आ जाएंगे graphs. And mind my terms, इसके graphs जो हैं हीट एंड थर्मोडाइनमिक्स के ग्राफ या थर्मल प्रॉपर्टीज ऑफ मैटर के ग्राफ्स, ये बहुत ट्रबल क्रिएट करते हैं. सो you should be very very patient with them. Then heat capacities, obviously heat capacity say at constant volume, at constant pressure, in सब से related भी you can actually encounter so many questions. So this session will obviously encounter and encompass the questions of all these subtopics, and we'll be solving them. I'll be giving you a very good analysis as well, कैसे किस अप्रोच के थ्रू हम जल्दी से जल्दी आंसर कर सकते हैं. साथ ही साथ ये भी बताऊंगा कि कहाँ गलती करने का एक एलिमेंट है, कि स्कोप भी है. ओके, सो सेशन बहुत ही ज़्यादा इंटरेस्टिंग होगा. अब हम बस सेशन स्टार्ट करने ही वाले हैं. सो अपने जितने भी आपके डिस्ट्रैक्शंस हैं अगले फॉर द नेक्स्ट 1 आवर, जस्ट डिस्ट्रैक्ट देम. जितने डिस्ट्रैक्शंस उनको तुम डिस्ट्रैक्ट करो कि दे गो टू समवेयर एल्स, एंड आपका पूरा फोकस सेशन की तरफ होना चाहिए. एंड द फर्स्ट क्वेश्चन व्हिच वी आर ब्रिंगिंग इन फ्रंट ऑफ अस इज ऑफ 2021, asked in JEE Main 2021, and this question is of bimetallic strip. Now what is a bimetallic strip? So bimetallic strips are very readily used. Have you ever wondered कि आपका refrigerator, is he got a brain that एक particular temperature के बाद वो after a particular temperature circuit break हो जाता है और वो ठंडा नहीं होता, कंप्रेसर कंडेंसर जो भी होता है वो बंद कर देता है अपना वर्किंग को. द रीजन बिहाइंड दैट इज बायोमेटालिक स्ट्रिप. जहाँ पे भी यू वांट दैट ऑटोमेटिक चेंज इन योर सर्किट, दे यूज अ बायोमेटालिक स्ट्रिप ओवर देयर. ठीक है, यू जस्ट यू शुड रिमेंबर, यू शुड एक्चुअली क्वेश्चन योरसेल्फ कि जस्ट विद द हेल्प ऑफ अ रिमोट I can fix temperature of an air conditioner, and the AC just tries and maintain that temperature of the room only. That's the reason why it is known as a conditioner, because it conditions that air, it maintains that particular temperature. And how is doing that? It is just by the fact of just breaking the circuit. It just prevents the flow of current. It just stops that compressor from working, and thereby stopping the exchange of heat. Okay, so the question is about that only. It's not about what is the application of bimetallic strip. It is actually कि bimetallic strip में function कैसे होता है, वो होती क्या है. and यहाँ पे they have given a different case. and what the case is कि a bimetallic strip consists of metal A and B. There are two metals A and B, okay. It is mounted rigidly as shown, so it has been mounted, not an issue. And bimetallic strip, obviously bimetallic, that means two metals. So A भी एक अलग metal होगा, B भी एक अलग metal होगा, ठीक है sir, perfect. The metal A has higher coefficient of expansion. So A has higher coefficient of expansion as compared to the metal B. When the bimetallic strip is placed in a cold bath, it will. So it should be cold bath में जब इस चीज को हम एक cold temperature में डाल देंगे, so इस bimetallic strip के साथ क्या होगा? What it will occur, and क्या होगा इसके लिए options भी हमें दे रखे हैं. Bend towards the right, not bend but shrink, neither bend nor shrink, bend towards the left. अब होगा क्या, देखो मेरी बात सुनो. Since A का अल्फा ज्यादा दे के रखा हुआ है, A का अल्फा क्या है, अल्फा A का ज्यादा है as compared to the coefficient of expansion of B, ठीक है, perfect. अब इसका अल्फा ज्यादा है, that means what, जो टेम्परेचर चेंज के हिसाब से इसके डायमेंशंस में चेंज होगा ना, वो ए का ज़्यादा होगा एज कम्पेयर टू बी. दैट मीन्स अगर आप टेम्परेचर बढ़ाओगे तो लेंथ ए की ज़्यादा बढ़ेगी, और टेम्परेचर कम करोगे तो लेंथ ए की सबसे ज़्यादा छोटी होगी, ठीक है. द कोएफिशिएंट ऑफ एक्सपेंशन, सो डोंट जस्ट कंसिडर इट विद एक्सपेंशन, इट इज ऑफ कंप्रेशन एज वेल. सो इफ यू जस्ट रिड्यूस द टेम्परेचर ऑल्सो, सी द रिलेशन इज ऑब्वियसली लाइक दिस, दैट डेल्टा एल will be equal to L alpha delta T. Okay, so if delta T is plus, that means temperature is increasing. Delta L obviously will be plus, that means expansion is occurring. But if delta T becomes negative, then delta L has to be negative, right? So the same thing occurs during compression expansion both. So if alpha is greater than alpha B, that means I can surely say that the change in dimension of A will obviously be greater than the change in dimension of B. Very well, sir, very well. Now, based on these changes, how I can say that whether the bimetallic strip will get curved or will bend towards left or right? For that I will have to draw circles. So obviously just imagine this circle. Imagine this circle. So what can you say about the circumference? Suppose both the circles have a same center. So what can you say about the circumference? So obviously the circumference of the outer circle will be more as compared to the inner circle. And if I draw the circle like this, then obviously the outer circle, which was at this position more circumference, which had more circumference, now will have a lesser circumference as compared to the outer one. So this is the case. If suppose temperature was increasing, if temperature was increasing, then the expansion in A had to be more than the expansion in B. That means it would have lied, or the compression or the changes would have lied somewhat like this. Are you getting my point? Because obviously the B metallic strip would have expanded in a very little amount as compared to the A metallic strip. A का expansion ज़्यादा होगा और इसीलिए वो outer region में आएगा एक circular region के. But यहाँ पे क्या हो रहा है? यहाँ पे compression होगा. क्यों? Because वो एक cold region में रखा जा रहा है. एक cold region में रख रहे हो आप, तो जो already उसका temperature है उससे कम पे जा रहे हो. That means temperature is decreasing. Temperature decreasing, delta L will decrease, and delta L, since it is decreasing, so what is the case now? The expansion, or actually the bending of this bimetallic strip, will occur somewhat like this. Are you getting my point? It will occur somewhat like this. So which option can better give the result of this? The option obviously D1, that is bend towards the left. मतलब ये पूरी की पूरी जो bimetallic strip है, ये कुछ इस तरीके से bend हो जाएगी, इस तरीके से. Are you getting my point? कुछ इस तरीके से ये bend हो जाएगी, something like this. ठीक है, and this will obviously be A and this will obviously be B, and this is justified, right? क्योंकि A जो है वो उसमें जो expansion होगा या compression होगा वो सबसे ज़्यादा हो जाएगा, तो it will bend, but B में compression थोड़ा कम होगा, and that is the reason वो इस तरीके से bend हो जाएगी. So I suppose you people have understood how we actually derive this result and how the option D is actually justifying this answer. So this will be the answer for this question, and do keep these concepts because they are very important. A bimetallic strip question is quite famous and they ask it very rapidly. Okay. Now let's move towards the second question, and the second question is all about two identical metal wires of thermal conductivities K1 and K2 respectively are connected in series. Okay. The effective thermal conductivity of the combination is. So there are two wires, and obviously thermal conductivity की बात हो रही है, that means heat transfer होगा. There has to be some heat transfer, right? And heat transfer चाहिए आपको, and heat transfer कौन से दो region के बीच में चाहिए? So there is this region T1 and there is this region T2. and what they're saying is two identical metal wires. Now two identical metal wire means their dimensions are same, that means the length and the area are same. Okay, so the length and the area of two wires are same. Now what it is saying is they are now connected in series. So the effective thermal conductivity of the combination is, now what do I mean by effective thermal conductivity is ki, see, let's just draw the first case. So suppose this is a wire, this is your wire 1 and this is your wire 2. Okay, and obviously they are of the same dimension, so I'll just use some different color to represent them. Okay, so this is your wire of length L and the cross sectional area of it will be A, and if I talk about the second wire, then obviously its length is also L and its cross sectional area is A, but there is a change in their thermal conductivities. So its thermal conductivity is obviously K2 and its thermal conductivity is obviously K1. Now what are they asking is the effective thermal conductivity of the combination is. So in place of that, between that same temperature range, you will have to place a length wire of length 2L, okay, and of the same area. So of the same area but length twice obviously, because during this, in place of that you will have to place a wire, right? So length will be 2L. Now they are asking what is the thermal conductivity of this wire. This is what they are asking. So we can very well do that, right? We can very well do that because we know the concepts of conduction. Obviously the heat transfer will be based on the principles of conduction. Current will flow through it from higher temperature to lower temperature, and the heat resistors, how the combination behave. So if you remember the concepts of series connection in current electricity, so those electrical resistors when in series, they added up algebraically, right? R1 plus R2 will give you the result of R effective, and if they were in parallel, then R effective was R1 R2 upon R1 plus R2. So the same analogy is over here as well. So if I talk about heat resistors, that means this is a heat resistor of heat resistance R1, this is a heat resistor of heat resistance R2, and obviously I want an effective one. So let the heat resistor be R equivalent. Let the heat resistor be R equivalent. So R equivalent will obviously be equal to R1 plus R2. And that's pretty that is pretty clear, right? That will be equal to R1 plus R2, right? Now what I need to do is I just need to replace this R equivalent in R1 and R2, and thereby in doing so I'll get the value of that effective thermal conductivity. Okay, so what is the value of R equivalent? So R equivalent is obviously, if you remember the formula of heat resistance, it was 1 upon K L by A, right, where K was thermal conductivity. So it will be 1 upon K, that is the effective thermal conductivity, into what is the length? What is the length of the equivalent one? It is 2L. So 2L upon A, and this will instead be equal to 1 upon K1 L upon A plus 1 upon K2 L upon A. Clear? Because those individual wires had their thermal conductivities as K1, K2 and individual length as L and area as A. Okay, sir, perfect. I can cancel this A and I can cancel this L, and if you're getting the result, so the result is somewhat turning to be 2 upon K is equal to 1 upon K1 plus 1 upon K2. And as you can see over here, if 2 upon K is equal to 1 upon K1 plus 1 upon K2, then obviously K is turning out to be, K is equal to 2 times K1 K2 upon K1 plus K2, and this is the result for the effective thermal conductivity. So is there an option? Yes, A option. Are we correct? We are absolutely correct. We are absolutely correct. Hi Raktim, how are you? And so this is the answer for this question, and I suppose you all have understood this question कि किस तरीके से what approach we followed, हमें इसको replace करना था same length की wire से. So if it was LL, then the replacement should have been equivalent to 2L, and 2L का wire लगाया, 2L का wire का जो thermal conductivity होगी, so here is the result. We just use the concepts of series connection, thermal resistance कैसे change हो जाता है, and thereby using that approach only we got the final result. So it was very beautiful, it was very easy, and इस तरीके से हमने कर लिया. अब the main problem over here with students was they used a wire of length L. Okay, so what they did was they equated this R equivalent by 1 upon K L by A, and what they instead got was K is equal to 2 K1 K2 upon K1 plus K2, which is an option as option D, but this is the wrong one, and this was that silly mistake which they were doing, and due to that they obviously got a negative in spite of a positive, despite the fact that they were knowing the entire answer. So this is the reason I placed this question, ki you should just get a hold of the language also, what that question is actually conveying you. See, people have always faced difficulty in in this expression also. Say suppose the length is increased by 5%, the length has become is becoming equal to 50%. So by becoming and reduced by, increased to, you should be very well aware of these statements, because students have always faced difficulty. I received so many queries from students that sir हमें ये question आता था but हमें वो चीज़ ही नहीं समझ में आई, increased to और increased by में difference नहीं कर पाए, and कैसे इस चीज़ को समझोगे? See, I cannot be your English educator, I could teach you. What you can do is, you can just practice as many questions as you can. On practicing so many questions, na, the mind only gives you, and previous year questions तो बहुत ही ज़्यादा important है. Because previous year questions करने से we get to know of that language, which language the physics paper has been asked. Obviously, nobody is asking you about your pronunciation, your vocab is not, nobody is taking that, but still you need to just grasp all those facts which are given to you in the question, and based on that you can actually create a mind map or a picture of the question or the data provided to you. Based on your existing knowledge, you can then derive something from the data and proceed with the final result. So that's a normal thing, and you should be doing it because it's lifelong learning, and your entire life is made up of that. You will be given with data, right? And based on the data you will have to give out some positive result, and this is how life is. So see, suppose these questions are actually a life lessons for you all as well, and you should, so entirely the summary is that you should practice as many questions as possible. And I obviously told you, you can practice questions from any book as well, not an irrelevant. There are so many relevant books, you can practice questions from those books as well. But if you want a platform where all the questions of all the standard books and very nice questions, previous year questions, and some unique questions which can actually boost up your existing knowledge, and if you want that platform, so you readily can available is in our app. You can just download it, in the description the link has been provided, so you can just go for it. You can just try as many questions as you like, and trust me, you'll just love it. You'll get used to it, because the pattern in which the questions have been designed, and even if you give the tests, what you will get to know is that in tests also, questions are actually asked in a very synced and very organized manner, that there will be few questions from this hot topic, few questions from this hot topic, and do give that trending test option as well, because most of the students are doing that, and the analysis report which you'll get over there giving that trending test will actually give you a very good and a clear picture that where you are standing presently. Okay. So do try that, it's my personal recommendation to each and every student who will be watching this series or will be watching this session. It's my personal recommendation, trust me. Based on my experience, I can very well tell you that the app is brilliant in itself, and you should definitely give it a try. Now let's solve this question of JEE Main 2021. Okay, so what this question says is, each side of a box made of a metal sheet in cubic shape is A. Okay, obviously there's a cube, so all the edges will be of the same length, and that is A. At room temperature T, the coefficient of linear expansion of the metal sheet is alpha. So obviously every object has a coefficient of expansion, everything contracts or expands a bit. So if I talk about this box, then the linear expansion coefficient has been provided to us, and it is equal to alpha. Okay, the metal sheet is heated uniformly by a small temperature delta T, so that its new temperature is now T plus delta T. Calculate the increase in the volume of the metal box. So we need to calculate the volume increase. Okay, what do I need to calculate? I need to calculate this value delta V. Okay, delta V. So I very well know the value of delta V, right? Delta V based on expansion will be equal to the initial volume, the volume at which I have been noticing things. From the volume I have been noticing their expansion or compression, whatever it is happening. So delta V will obviously directly depend upon its volume and the coefficient of volumetric expansion, that is gamma, and the change in temperature. Very true, very true. But do we know the value of gamma, that is the coefficient of volumetric expansion? No, we don't know. So what we are given with? We are given with the coefficient of linear expansion, that is alpha. So how to actually relate both of them? So you all must have seen that alpha, beta and gamma are related, but do you know how they are related? So in the question, nowhere it's mentioned that the expansion is occurring in an isotropic fashion. So isotropic fashion means that if length is increasing by delta L, then an equal amount area will also increase and the equal amount volume will also increase. So that's called an isotropic expansion, wherein the expansion occurs uniformly along all directions. So if it is not given, we will have to assume, and we will have to assume that, and based on that assumption, what I can say is gamma will be 3 times alpha. So if there would have been beta, then it would have been 2 times beta alpha. Okay, so gamma is obviously 3 times alpha, and volume, you very well know what is the volume of a cube, so it's a kiddish question in itself. So volume is obviously a cube, and gamma will be 3 times alpha, and the delta T is already given to you. So you can very well calculate the value of delta V, and this is the answer for this question. And obviously it was a simple one but students face difficulty in relating alpha and gamma. So there are so many things, sometimes I feel it was such a clear cut answer right in front of you, a one liner. It was just a one liner question, just viewing it and you'll get the answer. But based on that question and so many, sometimes text also, students fear of the text even. If a question is made up entirely of text, it's one big passage, and they just avoid it by their first look itself. And the reason to that are actually they don't have enough time, first of all. And the next thing is, they just think, yeah, who will spend so much time in extracting knowledge from such a big passage? They should have given a one liner and a diagram, and that would have been much easier. But the case is not always that, and you can expect such questions, and it was obviously a question of 2021, but with so much text, student faced difficulty and they avoided this question, which was instead a one liner. So you should always have that time of just reading a question, okay? And do try this approach. I also tried it, that I read the question once, and out of that first reading, I could extract some around 40-50% of the data given to me. But still that storyline wasn't created in my mind, that what should be the approach. Then I read it the second time, and sometimes I had to read it the third time even. So initially I had to read it 3 times, but by the time I was on that final exam, wherein I just gave that, in my time AIEEE was there in place of JEE Main, and IIT JEE was there in place of JEE Advanced. So IIT used to happen earlier, and JEE Main, that is occurring previously to JEE Advanced right now. AIEEE was occurring at the last. So I gave that paper, and during that exam, what I felt was that I was very easily able to decode the information given to me in my second read itself. And I actually developed that ability just few months back, just by practicing so many test series and all. And obviously all of your crash course is also running right now. So it's completely free of cost, and you should do visit it. And also one more very important news, you must have been updated in the crash course even. Tests, your tests have been live on the app, and you can just download it and practice it, okay? So there's no amount of charge to just give that test. So you can just practice that and get that analysis report as well. And slowly and very recently only, we'll be releasing the test series as well for you people, which will be a cumulative 3-hour fashion test for you people, strictly according to the standards of JEE Main. And you need to practice them as well, because they will actually give you a very good insight, and will definitely give you an insight about how well you have been performing and how well you are right now. So what is your rank among all those peers, which are obviously at that day you have to compete all over India, right? So you should get a clear picture from this day even. And very recently NTA will be releasing the dates. Don't worry, this week or the other week NTA will be releasing the dates about JEE Main, and then it will be a running race for everybody. So time is now. You should actually get involved in all these things. You should just watch these channels and try utilizing your time to its fullest, and that is actually very good, and it can actually improve your score as well. Okay, so I suppose this question was very clear to all of you. Now let's move ahead and solve this another question of graph. As I told you, graphs question are very frequent. So for the given cyclic process CAB as shown for the gas, the work done is, so what will be the value of work done? And obviously, see, suppose in a PV curve, obviously the work done is the area of the triangle, right? And I just wanted to explain you a bit further. So from C to A, what is happening is expansion is occurring. So there will be positive work done. From A to B, what is occurring is See the arrow is moving downwards, so there isn't any volume change. That means no work is being done. And from B to C, again, the direction is like this. That means volume is decreasing, and volume is decreasing means work is not being done on the system, or sorry, work is not being done by the system. Work is being done on the system. And in physics, if I talk about work done, so whenever work is done by the system, it's considered positive, and work is done on the system, it is considered as negative, because work has been defined as W is equal to integration P dV. So if dV is positive, then work is positive. If dV is negative, work will obviously be negative. So what can you say about the work done over here? So it will obviously be positive. It will obviously be positive. Just by changing the direction of arrows, I could have made this work as negative, and there could have been options of positive, negative as well. They were very lenient to you. They didn't give any options of positive and negative, but you can expect that over here the arrows might have changed, and you just have calculated the area of the triangle and said, okay, the work done is this in a positive figure. But just by the change of these arrows, the answer would have just turned out negative from its positive value. Now what is the figure? So can you just calculate the triangle's area? It's very simple. It's just half base into height. So this base is obviously 1 to 5 is 4, and this length is 5. So 4 by 2 is 2. 2 into 5 will obviously be 10. So the answer is 10, and I suppose I am right, and you are absolutely correct, sir. So this is the right answer for this question, and I suppose you got the idea behind how we actually dealt with this question. See, suppose thermal properties of matter, you won't find a question which is of the extreme limits. Okay, here always language plays a role. Based on the language, people get confused, students get confused. And if I talk about the question level, so it's not of that extreme level. If you are well aware of the concepts, some basic formulas, what is actually in the strategies and how your teachers have taught you, just the lectures and few standard questions and just a practice can actually give you a very good score, and you might not fear this chapter even, because the questions are very interrelated. You just have to get the insight, the exact what I mean to say, the crux of that topic. So the crux of thermal properties of matter, if you have got hold of that, what conduction, radiation and convection is, what all are the expansion coefficients and how volumetric, areal and superficial expansion occur, you will get a clear insight, you will get a clear viewpoint about the entire chapter, and that chapter won't be a big trouble to you even. Okay. So now let's solve this question of 2019, another graph based question. So following figure shows two processes A, B for a gas. If delta Q and delta QB are the amount of heat absorbed by the system in two cases, and delta UA and delta UB are changes in internal energies respectively, then what can you say about which of the following is correct? See, suppose one thing very clear. Internal energy is a state variable. Okay, internal energy is a state variable. And what do I mean by state variable? So it will depend upon its initial state and final state. So if both are same, then what I can say is that the change in internal energy will be 0. Okay, so if I can observe that there are two processes running and both of the processes have their initial and final points have same, then what I can be very specific about is there will be a change in internal energy, obviously, because the final and initial positions are different, but the changes will be same. So that means the delta UA when I go from A to B, from I to F along A path, and delta UA when I go along B path from I to F will be same. And what all options do they offer us? Yes, so over here it's same, over here it's same. So without using a lifeline, I was very easily able to cut two options. Now I just have to shortlist one out of them. So in such a manner, if I talk about probability, then 50% of my chances are that I'll be right. Even if you don't know the rest of the method, you can just give a a random guess, and 50% chances can be that you are right and you are not wrong. Okay, so but we will not guess, we'll actually find the true result. So the rest about delta Q and delta QB, how can we finally get to it? So we'll be using first law of thermodynamics. So delta Q is what? It is delta U plus delta W, right? And delta W, okay, just wait for a while. Delta W, if I talk about delta W, what is the method of calculating the value of delta W? So delta W is area under the curve, area this curve is making with volume axis, because work is, delta W is integration P dV. Now what is P dV? P dV's integration is actually area under the curve, right? So which of the area is more? If which of the area is more? See, delta UA is same for both of them, right? This is same for both the processes, process A and process B. Now if I talk about work done, then work done obviously will be greater for this process going through path A as compared to the process going through path B, right? So the work done over here will be more as compared to the work done in B, and then I can very clearly say that okay, the delta Q of A will be greater than delta Q of B, right? So since work done, change in work done delta W A is greater than delta WB, I can very well say therefore delta QA will be greater than delta QB. And is there an option justifying this fact? Yes, there is option C, and I have very clearly gave you this result, that how I actually find out this result, and this is the right answer for this question of 2019. It could have given you a positive score. Okay, so now let's move ahead and solve this one more very important question, where this equation frightened the students, that what kind of a stuff now has arisen, because we always studied PV is equal to nRT. Apart from that, we haven't studied any equation, right, of PV to the power gamma is equal to constant and some few processes of isochoric, isobaric. Now what the hell this equation is? So I'll just tell you, there was nothing in it. There was seriously nothing in it. You just had to replace this value. A process can be given of any equation, the variables can be related in any fashion, and what you need to just do is you need to be more proactive towards solving questions, that always the scenario will not remain same as you have been taught or as you have been doing questions. There always be some moderations and alterations, and it's you, the exam wants to check that ability of yours, that in a tense, in a very rough atmosphere, how well you can perform when the chips are down and when winds are blowing at a very fast pace. Are you that stable enough that you will not loosen up your grip over that? And these questions are actually designed for that only. So there was nothing actually, you just had to use your brain and just replace these values of V naught and calculate the value of P, and instead for that find the value of temperature, and you would have very well done that. So now let's solve this question. So what it says is 1 mole of an ideal gas passes through a process where pressure and volume obey this relation. Okay. Here P naught and V naught are constants. Calculate the change in temperature of the gas if the volume changes from V naught to 2V naught. So initially the volume was V naught and finally it changed to 2V naught. So what will be the change in temperature? So what I can do is, at this point I'll calculate the value of temperature. At this point also I'll calculate the value of temperature, let that be T21, and then I'll just do T2 minus T1 and give you the final result. So can I do that? Yes, I can. How I'll do that? What I'll do, at this volume I'll place this V as is equal to V naught and find the value of P. So at V is equal to V naught, what is the value of P? P will turn out to be, see, P naught 1 minus 1 by 2, here in place of V, V naught will arise. So V naught will get cancelled, 1 by 2, 1 minus 1 by 2 is 1 by 2. P will turn out to be P naught by 2. Simple? Yes sir, very simple. Okay. What about the other case? What about the other case? So at V is equal to 2V naught. Now what will be the case? Just replace this V by 2V naught. So it will be 1 by 2 whole square. And 1 by 2 whole square and 1 by 4. 1 by 4 into 1 by 2 is 1 by 8. 1 minus 1 by 8 is 7 by 8. 7 by 8 into P naught will be, so P will turn out to be 7 by 8 P naught. Very well, very well. Now what can you say about the temperature? So it's an ideal gas, yeah. It's an ideal gas given to us. So PV will be equal to nRT. And using that relation, I can very well decode the value of temperature. So T will be equal to whatever is the pressure and volume divided by nR. And also 1 mole has been given to us, so nR means only R, because n is equal to 1. So over here it will be P naught V naught by 2 into R divided by nR. So this is R, right? So this will be the value of T1. Now if I talk about T2, then what is the value of T2? It will be PV upon nR. So what is P? It is 7 by 8 times P naught into V is what? It is 2V naught divided by R. N is obviously 1, right? So this is the case, and I just can cancel it up. So it will be 7 by 4 times P naught V naught by R, and also here it is P naught V naught by 2R. I can do one thing, I can just multiply 2 over here and 2 over here, and why I'm doing that, because now the denominator will be 2 P naught V naught by 4R, and here it is 7 P naught V naught by 4R. So what will be the change in temperature? That is T2 minus T1, and this is instead 7 by 8 minus 2 by 4 into P naught V naught by R. I suppose you have just understood this result. Here it is 7 by 4 P naught V naught by R, here it is 2 by 4 P naught V naught by R. So what is 7 by 8? Sorry, not 7 by 8, 7 by 4. It's not 7 by 8, it's 7 by 4. I just cancelled that 2 with 8, right? So it will be 7 by 4. Now 7 minus 2, obviously 5. So 5 by 4 P naught V naught by R. This is your answer. Let us see कि मैं सही हूँ कि गलत हूँ, और मैं एकदम सही हूँ और मुझे मिलते हैं प्लस मार्क्स. ठीक है. So सब मुझे I think you just understood this idea what it was. You just need to calculate the values of P naught V naught and this, then use this equation of ideal gas equation and derive the result of temperature, and this do that minus T2 minus T1, you will get the final result. So it was an easy one, it wasn't a tough one. All in all, what was required is that you had to be that analytical to actually decode the path, the process in which you should proceed, and then only you can find this result. Some students tried finding delta V from here itself by differentiating and all that, but that wasn't required. The normal approach was like this only. Okay. So with this we'll just move on to the next question, and the next question over here is that a thermometer is graduated according to a linear scale. It reads a value of x naught when in contact with boiling water and x naught by 3 when in contact with ice. So what is the temperature of an object in degree centigrade if this thermometer is in contact with the object that reads x naught by 2? Okay, no problem. So what I'll be using is, just wait for a while. So let's say it was saying that the reading x is equal to how much? X is equal to x naught when temperature is boiling water. Boiling water means 100 degrees centigrade. Okay. X is equal to, x is changing to x naught by 3 for temperature 0 degree centigrade. Now they want is when x is equal to x naught by 2, then what is the value of temperature? They want that. Okay, no problem, no problem. What I'll be doing is, I'll be just using the methods of linear. I'll just make, because since they are changing in a linear fashion, so I'll just use this formula. Okay, just give me a while. So what I'll be doing is, I need to find this temperature at this value of x. So I'll be relating this relation with any one of these values. You can take it with this as well, you can take it with this as well. So over here temperature is 0, so I'll most probably take this and this into account. So I'll write an equation like x minus, what is the value of x naught over here? So it will be x naught by 3 divided by, so this is the difference between these two values, and divided by the difference over here, so it will be t minus 0 obviously. This difference which I have just mentioned will be equal to the difference between them, the ratio of the difference between them, right? So I can just mention it that way, that x naught minus x naught by 3, this will be equal to x naught minus x naught by 3, and this will instead be equal to x naught minus x naught by 3 will be equal to 100 minus 0. Very well, this is the case. Using this method I can very well calculate the value of t and all, right? So x यहाँ पे जो है, that is, इसकी value कितनी है? It's equal to x naught by 2, so I can just replace it by x naught by 2, right? So यहाँ से क्या मैं t की वैल्यू नहीं निकाल सकता? डेफिनेटली निकाल सकता हूँ, बस मैंने रेट ही तो किया इन दोनों के डिफरेंस, और इन दोनों के डिफरेंस का एक रेशियो ले लिया और वो बराबर ही होगा. सो यूजिंग दैट रिजल्ट आई कैन वेरी वेल कैलकुलेट द वैल्यू, राइट? अब यहाँ से देखो आप, x नॉट बाई 2 माइनस x नॉट बाई 3, दोनों के डिनोमिनेटर सेम करो, यहाँ पे 3 3 और यहाँ पे 2 2 मल्टीप्लाई करो, सो इट विल बी 3x नॉट बाई 6 2x नॉट बाई 6, दैट विल टर्न आउट टू बी x नॉट बाई 6, सो इट विल टर्न आउट टू बी x नॉट बाई 6 इंटू t, एंड दिस विल इंस्टेड बी इक्वल टू, यहाँ x नॉट माइनस x नॉट बाई 3, दैट इज 2 टाइम्स x नॉट बाई 3, and over here it is 100. ये x नॉट से ये x नॉट कैंसिल, राइट? ये 2 से कैंसिल, ये वाला 2 50 से कैंसिल, और ये 25 से कैंसिल. सो t की वैल्यू कितनी आ रही है? द वैल्यू ऑफ t इज टर्निंग आउट टू बी 25 डिग्री सेंटीग्रेड. सो इज इट द राइट आंसर? यस सर, इट इज एब्सोल्युटली द राइट आंसर. हाय आदित्य विक्रम, हाउ आर यू? आर यू एक्साइटेड? बताओ आप एक्साइटेड हो? अब देखो, सो जो करेक्ट आंसर है वो आंसर है 25. 25 इज द राइट आंसर उस टेम्परेचर पे जब जो थर्मोमीटर है वो x नॉट बाई 2 रीडिंग शो करेगा. दिस अप्रोच इज ओनली यूज्ड इन फ़ारेनहाइट स्केल, इन सेल्सियस स्केल, रिलेटिंग सेल्सियस स्केल विद केल्विन स्केल एज वेल, कि इस टेम्परेचर पे ये, इस टेम्परेचर पे, तो बताओ इस टेम्परेचर पे कितना होगा. So using this method you can very well relate those two scales. Okay, ठीक है. So this thermometer was another object जिसकी scale I wanted to know, and there was another scale wherein I have already mentioned measured in degree centigrade the value of temperature of boiling water and ice. So this is the approach used to actually relate two scales of temperature and two scales of any other scales, meter, centimeter can be related using this approach. So this is a very common method, and I suppose you all must be knowing it. If you are not knowing it, just get hold of this, and through that only we cleared this JEE Main 2019 question. Now let's solve this another question, which is actually the conversion of gas. Choose the correct PV graph of an ideal gas for a given VT curve. So this VT curve has been given to us, and now we need to, based on this VT curve, we need to decide which of the curves is right. I can very well do that. I can very well do that. See, I'll be using in the questions of interconversion of graphs wherein 4 options are given. I can very nicely use that elimination of options method to eliminate the wrong ones, thereby limiting the result to just one option, which obviously has to be correct if the question is not wrong in itself. So I'll be using that approach only. Just wait for a while. So what I can see over here is from Z to Y. What can you say about from Z to Y? So from Z to Y, the volume is increasing. Okay. The volume is increasing? No, it's not increasing. It's an isochoric process over there. So volume is constant. So just look for Z to Y over here. Z to Y over here. Z to Y, volume is constant? No, it is not constant. Rejected. Over here, Z to Y, volume is constant? Not constant. Rejected. Z to Y, Z to Y, Z to Y. Wait for a while. There must be some problem over here. It's a PV curve, it's a VT curve. These values must be changed. If I talk about X to Z, from X to Z, V and T are directly related to each other, right? So V and T will be directly related, that is, V will be directly proportional to T. And in which case P is directly proportional to T, the case is of isobaric process. So isobaric process from X to Y. Which of the processes from X to Y? If I talk about X to Y isobaric, so this is the case and this is the case. And obviously from X to Y, the both volume and temperature are increasing, but pressure remains same, right? Volume is increasing, right? So volume is increasing. So this will obviously be the right answer. But and Y to Z, yeah, Y to Z, volume over here, here also volume over here. So this obviously is the right answer, right? Because Y to Z is constant, the volume is constant only in this process. If you look over here, then Y to Z, volume isn't constant. Y to Z, volume isn't constant over here itself, and Y to Z, volume is not constant over here itself. This is the only process where Y to Z, volume is constant. Even Y to Z has been decided that volume is constant over here. Volume is constant, and if I talk about over here, V is constant, and if I talk about this process here, P is constant. And how I came to this result where P is constant? Because obviously this line, if you see, it's passing through origin, so V will be directly proportional to temperature. And in which ideal gas equation V is directly proportional to pressure? PV equals to nRT, right? So if V is directly proportional to temperature, then obviously P will be constant, and P constant means this has to be the curve. From Y to Z, this has to be curve. So obviously based on rejections only, B, C and D are not right, and A is the correct answer. And are we right? Yes, obviously we are right. Okay, so I suppose you have just understood this result, and how we actually find this found out this final result. किस तरीके से हमने elimination of options use करके हमने 3 गलत options को ही eliminate कर दिया, and we got the final result. Now this another PV curve question, very important one, is for the given PV graph for an ideal gas, choose the correct VT graph. Process BC is adiabatic. Okay, so process BC इन्होंने बोल दिया है, it is adiabatic. Now we need to choose which of the VT curve is right. ठीक है, no problem, no problem. Let's do that part only. So from C to A, as you can see, volume is decreasing, but pressure is same. Okay, from A to B, as you can see, volume is constant. So which of the functions have A to B as volume constant? A to B, A to B. A to B, volume is constant. So A to B, volume is constant over here. A to B, volume is constant over here. A to B, volume is constant. Here it is not constant, so this is rejected. Okay, sir, perfect. Then if I talk about A to C, then in A to C, what is occurring? Pressure is constant. Pressure is constant. So for pressure is constant, what can you say about if P is constant, then obviously V will be directly proportional to T, right? PV equals to nRT. This is an ideal gas. Yes, this is an ideal gas. So if P is constant, as you can see from process A to C, C to A, whatever it is, the pressure is constant. So that means V and T will be directly proportional to each other. That means it will be a straight line. So from C to A, this is a straight line, this is a straight line, this is even a straight line, right? But from C to A, volume is decreasing, right? So in which cases volume is decreasing? Over here volume is decreasing, over here volume is decreasing, but over here volume is not decreasing, so this option is also rejected. Okay sir, perfect, perfect. Now the main bone of contention is remaining is C to B. So from B to C, if you view it, what can you say about the value of temperature? So this is an adiabatic process obviously, and in adiabatic process, if you very well know, so we have only A and B options remaining, right? So in adiabatic process what occurs is delta Q is obviously 0, that means delta U will be equal to delta W minus of delta W. So what is occurring over here from B to C is volume is increasing, right? Volume is increasing. That means work is being done by the system. Work is being done by the system because volume is increasing, my brothers. Volume is increasing. Well, volume is increasing. That means P delta V is positive, and P delta V is positive with a negative sign. That means delta U will be negative. And if delta U is negative, so delta U is what? It is NCV delta T, right? So if this is negative, that means delta T will be negative. That means temperature will decrease. So temperature should decrease. So when in which of the curve from B to C temperature is decreasing? Just tell me. So over here temperature is decreasing? No. Over here temperature is decreasing? Yes. So which one is the right answer? A is the right answer. Are you getting my point? किस तरीके से हमने आंसर निकाला? हमने पहले इन दो को किया और दो को एलिमिनेट कर दिया, फिर इन दो के बीच में कंफ्यूजन थी, बट एक चीज आई कैन नोटिस फ्रॉम दैट पॉइंट एज वेल, यहाँ पे टेम्परेचर डिक्रीज कर रहा था, इंक्रीज कर रहा था. As you can see, यहाँ पे टेम्परेचर इतना है, बाद में टेम्परेचर इतना, टेम्परेचर वाज इंक्रीजिंग, एंड ओवर हियर इनिशियल टेम्परेचर वाज दिस, फाइनल वाज दिस, दैट मींस टेम्परेचर वाज डिक्रीजिंग. सो आई नीड टू बी वेरी श्योर वेदर टेम्परेचर इज इंक्रीजिंग और डिक्रीजिंग. सो टेम्परेचर इंक्रीज कर रहा था, डिक्रीज कर रहा था, ये मुझे पता करना था, एंड आई यूज्ड दिस कॉन्सेप्ट दैट इन एडियाबैटिक प्रोसेस डेल्टा क्यू इज 0, thereby coming to this final result of delta T. Okay, ठीक है सर. फाइनली नेक्स्ट क्वेश्चन पे चलते हैं. बड़ा अच्छा क्वेश्चन है. व्हाट इट सेज इज n moles of an ideal gas with constant volume heat capacity. So constant volume heat capacity है, they are not mentioned whether it is molar heat capacity or specific heat capacity, it is just heat capacity. So what is heat capacity? If I talk about heat capacity, let that be capital CV, so it will be equal to n times molar heat capacity. Okay, n times molar heat capacity or m times specific heat capacity. And if it is volume, then it is constant volume. If it is at constant pressure, then it is at constant pressure. Okay, are you getting my point? So this is the result. This is the result. So I need to find the ratio of the work done in the process to the heat supplied. Okay, so it is undergoing an isobaric expansion. Not a big deal, not a big deal. An isobaric expansion. So what happens in an isobaric expansion? In an isobaric expansion, P is constant, right? And if P is constant, so first law of thermodynamics says delta Q will be equal to delta U plus delta W, right? Perfect. And what we need to find? We need to find the ratio of work done to the heat supplied. So the ratio should be of delta W is to delta Q. So what will be the value of delta W? So in case of isobaric expansion, what happens is work done is integration P dV, right? And since this is constant, it just comes out of the integration, so it turns out to be integration dV, that turns out to be P delta V. Clear? Yes sir, perfectly clear. So this will turn out to be P delta V divided by delta U plus delta W. Now what will be delta U? It is NCV delta T, when CV is molar heat capacity, but over here we are given with only heat capacity, only heat capacity. So that will be NCV, in place of NCV it will be this capital CV. So that will be equal to capital CV into delta T plus P delta V, right sir? Perfectly clear, perfectly clear. Now what is the value of P delta V? So it's an ideal gas, so PV is equal to nRT, right? Just using the delta on both the sides. So P is, since P is constant, since P is constant, I'm doing the delta on both the sides. Since P is constant, it will come outside. So P delta V will be equal to nR delta T, right? And just replace this value of P delta V equals to nR delta T over here in place of P delta V, and you'll get the final answer. So this nR delta T so this ratio will turn out to be nR delta T divided by CV delta T plus nR delta T. Delta T, delta T, delta T gets cut, and finally what you're remaining is nR upon CV plus nR. So is it the right answer? Yes, this is the right answer. So now I suppose you just understood this result. It was a very simple question. All you just had to go through was that heat, what is heat capacity, and it is way different from molar heat capacity. If there would have been molar heat capacity, then I would have used NCV delta T, but the mention was only of heat capacity. Okay. So based on that result, we calculated and found the final answer. So this will be the end of this session and the last question over here. So now what you need to do, these were not entirely all the questions which have been asked. Obviously there were more, they were just few selected questions, and if you want to practice more and more such questions of previous years, JEE Main and JEE Advanced, I can tell you a very best location, that is Extramarks the learning app. Go in that, select your JEE segment or class 11, 12th, whichever class you wish for. Just make out some filters and you can practice as many questions as you can. You can see over here, there are so many filters over here, then there is Q&A and recently viewed questions of chemistry. Even it gives you this difficult, the question is difficult, or the question is moderate, or it is easier. If you are getting an easier question difficult for yourself, then obviously you are in serious trouble. And you can very well know that what is the level of questions. Apart from that, you can give this test feature, trending test, mock test, so many things are there, and the UI is also brilliant in itself. You will not be searching for things because you will be getting them very easily. Okay, so do practice them. They are seriously very good and designed only for your betterment, and we will be meeting in the next session, that is on 14th Feb, very important date. So all of you must be present over there, and the topic will be kinetic theory of gases and thermodynamics. Very, very important. So we'll be discussing about very important things and concepts over here as well. Here also there will be curves. Here also there will be so many questions based on first law and second law thermodynamics. So do attend this session. It will definitely be beneficial for you guys. This will be the end of this lecture. We'll be meeting in the next one. Till then, thanks. Bye bye. Happy learning.